If you focus on success, you'll have stress. But rather, if you pursue excellence, success will be guaranteed. Hello everyone, myself Nigar Sultana. Welcome back to R&D Digital Learnings. In our previous videos, we have discussed what is theory of computation, what are languages, what are finite automata. In this video, we are going to discuss about the DFA, that is Deterministic Finite Automata. Let's solve the problems on DFA in this video.
Let me start with the Deterministic Finite Automata. It is also called as DFA. First, let's understand the definition of DFA. What is DFA? As I have told you, sigma indicates the input alphabet. So, this is your input alphabet. For each input alphabet, there is a way or there is a path from one state to another. For each input symbol, sigma which is equals to, like we have got A, B, C, etc. These are an input symbol. For each input symbol, there is a deterministic state. That is, there is a deterministic, suppose this is A. For A alphabet, there is a particular state to which a machine will move from one state to another. Suppose if I take another, so there is another alphabet. Now, why it is called as finite machine? As this DFA has finite number of state, hence it is called as deterministic finite machine. Now, let me see how to represent this DFA. In the representation of DFA, it contains the 5 tuples. Which are the 5 tuples? M is equals to Q, sigma, delta, Q naught and F. What is this Q, sigma, delta, Q naught and F? This Q is nothing but a set of states, that is a finite set of states. What is this sigma? Sigma indicates the input symbol. Next is delta. Delta is a transition function which is written as delta Q into input alphabet which tends to another state. Next, what is this Q naught? Q naught is our starting state. F indicates your final state. These are the 5 tuples of DFA. I'll show an example how the DFA will be. Suppose we have 3 states, Q naught, Q1, Q2. Q2 is our final state with double circle. This is our starting state. Now, you have an input symbol as 1. And 0. This is an example for the DFA, wherein for each input symbol there is a deterministic state. From Q0 to 0 input is Q0 itself. From Q0, 1 input is moving from Q0 to Q1. From Q1, 1 input is moving from Q1 to Q2. 0 input is going to the same state. Next, from Q2, there is an input 0 and 1 moving from the same state to the Q2 itself. Now, let's see what are the different problems we are going to solve in DFA. First type is the pattern recognition problem, divisible by K problem and modulo K counter problems. In this video, we are going to learn only the problems based on the pattern recognition problems. In our later video, we are going to learn 2 more type of problems, that is divisible by K problem as well as modulo K counter problems. So these are the steps we are going to follow while solving a pattern recognition problem. What is our first step? In the first step, we are going to identify the string, which is a minimum string. Next, in the second step, we are going to identify what are the alphabets we are going to use. Suppose if we have the alphabets like A, B or the alphabets like 0, 1. These are the alphabets. Next, with the help of these alphabets and the minimum string, we are going to design or construct the skeleton. This is your third step. Now the fourth step, after constructing the skeleton, now we are going to find what are the other transitions which have already not defined in the step 2 and 3. At the last step, after constructing a transition table, with the help of the transition table, we are going to construct a final DFA with the help of the transitions. Now let's understand this with the help of an example. First, problem states thus: draw a DFA to accept strings of A's having at least one A. That means what? Now let's see what is our strings will be. The strings can be, they are telling us at least one string, at least one A. It can have 1, 2, etc. So the minimum is 1A. So AA, AAA, then 4 A's, etc. So our condition is at least it must have at least 1 A. This is our condition. Now what is the first step? We need to identify the minimum string. So the first step, step 1. Identify the minimum string. What is our minimum string? That is single A. This is our first step. Next, what is step 2? Step 2 will be identify the alphabets. Identify the alphabet. That is sigma is equals to, which alphabet we are going to use here? A. So only A is the alphabet. Step 3. What is the step 3 says? Construct the skeleton. How to draw this? How to draw a skeleton? So they are talking only about a single A, right? It must accept on at least one A. That is, so at least if for transferring there will be one state. This is your start state. Now I want that at least A input. So it has to move to some other state. This is our final state. So now this skeleton of DFA is accepting A. Yes. Start. This is being accepted. Okay. Next. So now we can see from Q0 there is an input, but from Q1 there is no input. So we want for each and every state there must be a single input. Now what is the fourth step? Fourth step is identify the transitions not defined in step 3. Step 4 is identify the other transition. Identify the other transitions which are not defined in step 3. Now we doesn't have A input from Q1, right? Delta of Q1. So this is missing. See, since after 1A, there can be any number of A's. So this is a minimum part of your DFA. Next, so this can be any number of A's. That is, we have infinite loop. So now what can I do is, so A is our minimum string. Now I can give a loop for this and it will become an infinite. So that any number of A's can be drawn from this state. So the fifth is step 5. So this delta of Q1 comma A has to move to the same state because it is undefined. So this can be a infinite number of times A can come across. Now what is the step 5? Step 5 is construct DFA. So now from Q0 there was an A. So already one input is defined in Q0. Now we want an alphabet or a symbol from Q1 as well. So it is moving to the same state. So this is your transition diagram. So this is your final DFA diagram. Now let's see how it can be defined. The DFA can be defined as the DFA can be defined as. So what are the tuples we are going to use here? DFA, which is equals to Q, sigma, delta, Q0 and F. What is Q here? Which are the number of states you have? Q0 and Q1. Next, what is delta? Sorry, what is sigma? So which symbol we are going to use? A. Next, what is Q0? So the starting state is Q0 itself. Then what is F? F is your, which is the final state. Q1 is the final state. Now let's draw a table, transition table. A input, and these are the states Q0 and Q1. So from Q0, A is moving to the Q1 state. Next, from Q1, A is moving to the same state, right on Q1. So this is your transition table. In this way, we are going to solve any given DFA problem. Let's solve another problem. Design a DFA for string that always ends with 0, 1. So already they have mentioned the alphabets as 0 and 1. So our first step 1 states that we need to write a minimum string. Well, see, already they have mentioned that always it must end with 0, 1. Ending must be 0, 1. See, here it can be any number, but the thing is it must end with 0, 1 itself. See, it can be 0, 0 or 0, 1, 0, 1, or it can be 0, 0, 1, 0, 1, anything. But the condition is it must end with 0, 1 itself. So our minimum string is 0, 1. Now what is our next thing? Next is alphabet. So already alphabet is given, write down the same thing, 0 and 1. How to draw a skeleton? So they are talking about 0. So it starts from a state. This is your 0 moving to another state. Next is 1. So this is your minimum string skeleton of DFA. This is your starting state. Now, the fourth thing is identify the transition which I have not defined. Identify transition which has not defined in step 3. So now we have only from Q0 only we have 0. We doesn't have 1. Now we need to draw 1 from Q0. And from Q1 there is only 1. There is no 0 input. And from Q2 there is no 0 nor 1. So now how will the table look like? 0 as well as 1. This is Q0, Q1 and Q2. So from Q0 1 is moving to Q1. We doesn't have 1 input from Q0. We need to calculate this. From Q1 there is no 0. We need to calculate, and 1 is moving to Q2. Next, from Q2 there is no 0 nor 1. Now these are the transition we need to calculate. So our actual skeleton was like this: Q0, Q1 and Q2, 0 and 1. We doesn't have 1 from Q0, then 0 from Q1 and 0 and 1 from Q2. Now we need to calculate the transition function of Q0 from 1. One input from Q0. Next, transition function from Q1, there is no input of 0. Next, transition function Q2 of 0 as well as 1. We need to calculate. Now, since the string must contain 0 and 1, means that the last digit must be 0 and 1. So, whatever we give 0, it must be to the same state, right? It must be given. So, already 0 is there. So, if you want to give 1, so now it must move to the same state. So, it is moving to the same state since the string can begin with any number. See, it has the condition is it must end with 0 and 1. Starting it can be anything, like it can be 0 0 or 0 1 1 0 1 1 or 3 0 or anything. So, hence we have given 1 to the same state. Next comes the from Q1 we need 0. Now, for this it must end with 0 1, right? So, 1 is already there, we need 0. So, we can give it to the same state. Then it will become 0 1 at the end of the string. Here it is Q1. Next, from Q2 there must be 0 as well as 1. So, what happens if we give 0 to the same state? It will be like 0 1 0, right? If we give to the same state, it can be 0 1 0, or if we give 0 1 and if we give 1 to the same, it will also be 0 1 1. So, it doesn't satisfy this condition that it must end with 0 and 1. Hence, we can give this 0 to Q1. This is your Q1. Now, Q2 to 1. So, 1, if we give to the Q1, what happens? It will be 1 and 1. So, it must not be end with 1 and 1. Hence, we have to give this 1 to the Q0 itself. So, this is your Q0. So, this is your final DFA. I'll draw once again. Q0, Q1, Q2. 1, 0, 0, 1. So, now let's define the DFA. DFA can be defined as D is equals to Q sigma delta Q0 and F. What is Q in this DFA? Q is Q0, Q1 and Q2. What is input symbol? We are going to use 0 and 1. Next, what is Q0? Q0 is Q0 itself. Then our final is Q2. Now let's draw the table. Input symbols are 0 and 1. Q0, Q1 and Q2. From Q0, 0 is moving to Q1. 1 is moving to the same state, Q0. Now, from Q1, 0 is moving to the same state, that is Q1, and 1 is moving to the state Q2. Next, from Q2, 0 is moving from Q2 to Q1. From Q2, 1 is moving to Q0. So, this is your starting state. This is your final state. In this way, we are going to solve the DFA problems.
Thank you for watching this video. Do like and share with your friends.